Hey guys, today is April 13th. I hope everybody had a wonderful spring break. Today we're going to start our trigonometry section. Just starting off with a review of right triangle trigonometry. So here we have a right triangle, and in order for us to define our trig ratios here, we're first going to have to mark an angle with our theta, because you can't define your trig functions unless you know what angle you're coming from. So I'm going to mark this angle down here as my theta. Okay, if you don't have a piece of paper in front of you, please pause this video and get out a piece of paper or notebook so that you can write this stuff down. That way you have it to refer to when you're doing your practice. Okay, so when you're marking your triangles, we always want to go with respect to theta when we're talking about opposite, adjacent, hypotenuse. Our hypotenuse is always going to be the angle that's across from our right angle. No matter where theta is, the hypotenuse is across from the right angle. Now, when we mark our opposite, we want to look at the angle that's marked and we want to travel across the triangle. This is my opposite side. And then the hypotenuse is just the one that's right beside your theta. So, I'm sorry, the adjacent. Adjacent is right beside your theta. Okay, then to define our trig function, your sine is the opposite over the hypotenuse. Your cosine is adjacent over hypotenuse. And your tangent is opposite over adjacent. And then you may or may not have seen these three trig functions before, but these are what we call the reciprocal functions. And I have it written this way because cosecant, that's the way this is said, cosecant is the reciprocal of sine, secant is the reciprocal of cosine, and cotangent is the reciprocal of tangent. So once you know your first three trig ratios, all you have to do is take the reciprocal, and that'll give you the other three. So cosecant is defined as hypotenuse over opposite. Secant is defined as hypotenuse over adjacent. And cotangent is adjacent over opposite. Okay, and then whenever you're doing these with numbers, you always have to keep in mind that if you have a fraction as an answer, which most of these you will, you want to make sure your fractions are completely simplified. And then you also want to make sure that you rationalize any denominators. So if you end up with a square root in the denominator, which happens sometimes, you just have to make sure you put it in proper form and rationalize your denominators. Okay, so I'm going to do one example for you. So we have this triangle here. Our theta is marked. So it's always a good idea to go in and mark which ones you're referring to as opposite, adjacent, hypotenuse. So again, across from your right angle, this is your hypotenuse. So my 13 is my hypotenuse. Across from theta, this is my opposite. As you can see, we don't have a value here. And then right beside my theta, this is my adjacent side. So in order to find this other measurement here, we're going to have to do our Pythagorean theorem. So a squared plus b squared equals c squared. You want to make sure when they're asking you to find the value of all 6 trig functions that you have all 3 measurements on the sides of your angles, of your triangle rather. Okay, so I'm going to do a squared plus b squared equals c squared, so I can do 5 squared plus b squared equals 13 squared. Go ahead and square it for 25 plus b squared equals 169. And then subtract 25 from both sides. B squared equals 144. And then you're just going to go ahead and take the square root of both sides. Since we're talking about a triangle, we're not going to use the negative value, of course. We're just going to use the positive. So b equals 12. So then my opposite side equals 12. So now I have all the information I need. So can you just go over to your trig functions, Your sine is the opposite over the hypotenuse. So opposite is 12, hypotenuse is 13. So 12 over 13. They're not asking you for the measurement of the angle. They're just asking you for the trig ratio. They want the answer as a fraction. Cosine is adjacent over hypotenuse, so 5 over 13. And tangent is opposite over adjacent, so opposite is 12, adjacent is 5. And none of those reduce, so we're just going to go ahead and leave it alone. And then whenever you go to find these ones, you can go back to your triangle if you want. Cosecant is going to be the hypotenuse over the opposite. Hypotenuse is 13, opposite is 12. Or you can just go ahead and take the reciprocal of sine. So all you have to do is take this and flip it over. It's 13 over 12. This will be 13 over 5. And this will be 5 over 12. And that's it. So that's how you find the trig ratios. So just a quick reminder on rationalizing denominators. So if you do your Pythagorean theorem and you end up with one of your legs of your triangle as a square root, then you want to make sure you rationalize your denominator. So for example, if I end up with something like this, 2 over the square root of 3, and that is my fraction, my trig ratio, you can't leave the answer like that. You want to make sure you rationalize your denominator. So you want to take and multiply top and bottom by the square root of 3. 2 times the square root of 3 is 2 square roots of 3. The square root of 3 times the square root of 3 is the square root of 9, which just gives us the number 3. So this is how we would want our answer to look. This answer here and this answer here, they have the same value. This is bad form, and this is good form. Okay, email me with any questions. Have a nice day.